Morning, guys. Hey, Ryan. Hey, Logan. What's up, Jacob? Jack. You guys like Zoom at all? Hi, Azra. No. Some of you do, some of you don't. I don't know how I feel about their security. Plus, I like being able to have these videos for you guys to reference whenever. Alright, so today's agenda. I'm going to do an entire review of the SEM Study Guide, 1 through 14, each part. Then, just brief, second part, just talk about the unit test tomorrow, talk about its format, talk about where it's going to be, when to complete it. And then the third part would be a Quizizz hosted right here on YouTube. People watching can join it and compete in it. All right. Even if you're not in chat, you can still join it. All right. Over in the upper left corner on all classrooms, A through D, it says Due Monday STEM Study Guide at 10 a.m. That was there just to remind you to have this study guide done for today, because if you are trying to complete it while I try to go over it, you're not benefiting from a review. Review should be finding out what you're lacking in terms of knowledge and being able to tonight double down on those things that you're weak in. That's what a review should be. Shouldn't be you trying to scramble down some answers. All right, it should be a confirmation of what you know, and it should be pinpointing what you need to focus on tonight. All right. So hopefully that's taken care of. You do not need to turn it in, but if you want to turn it in so it doesn't say missing in red in Classroom, you're using Classroom now more to see what's missing, what isn't missing, then just turn it in. Have peace of mind. I don't care. All right. So a lot of questions. I'm going to get started right on it. What is rotation from part one? What is rotation rate of the Earth and the Moon? Hi, John. What is revolution? What is the revolution rate of the Earth and the Moon? Making a model using common materials, or just at least be able to make a diagram and understand how a model would work with some common materials, like you're modeling the SEM system. And then, why does day and night exist? All right. So, part one, first question, the rotation of the Earth and Moon. Rotation is, hi Charlie, spinning of an object on an axis, right? That's what rotation is. And just keep in mind that, let me get this out of the way. There we go. Keep in mind that an axis is an imaginary point that connects a north pole and a south pole, all right? Top and bottom of an object. That line runs in between those 2 points. It's not like an equator. The equator goes around the midsection of the planet, especially the Earth, and it lies on the outside. It goes the circumference of the planet. The axis goes right through the planet from north to south pole. And we're talking about the spinning on that axis. All right. For the Earth, one rotation takes 1 day, or about, on average, 24 hours. For the Moon, it's going to take 28 Earth days, 28 days to complete one rotation. Right? The lunar cycle is 28 days, 27 to 29, depending on who you ask and what you're using to measure. But 28 Earth days will make one moon day, one rotation of the moon. All right. The next question would be the revolution. Revolution is the movement of one object around another. Very similar to the word that we're going to be using more after we talk about the sun, earth, and moon, and that's orbit. Okay? movement of one object around another. For the Earth to go around the Sun, because planets orbit the Sun, take 365 and a quarter days. For the Moon to go around the Earth, because moons orbit planets, it will take, once again, 28 days. So the rotation and revolution for the Moon is the same. The rotation and the revolution for the Earth is different. Rotation for the Earth is 1 day, 24 hours, and then the revolution of the Earth around the Sun is 365 and a quarter days, which is why every 4 years you get a leap day. Because if you don't offset those quarter days, you're going to have your calendar get out of sync. You don't want that to happen. Hi, Maddie. So then number 3, just keeping in mind 1 and 2 when you're starting to think of a model, apparent size, apparent scale, the Sun should be larger than the Earth, and the Earth should be larger than the Moon. Technically speaking, if you want to be real precise, which you would want to be, the Sun should be much larger than the Earth is compared to the Moon. So the Earth and the Moon should be more similar in size. However, the Earth is definitely bigger. All right? So the Sun, the Earth, the Moon. I put them in order of size, right? The Earth is closer in size to the Moon. The Sun is enormous compared to those objects. All right? So now we know that they move in a revolution. Well, the revolution is counterclockwise. So these two objects are moving in a counterclockwise orbit or revolution around the closest, largest, massive object. So the Moon's going in a counterclockwise orbit, the Earth's going in a counterclockwise orbit. So the Moon would continue going there, and the Earth would continue kind of going off screen, all right, through those answers. If we put 365 days instead of 365 quarter days, would it be wrong? No, I don't think so. Because you might want to be using that in your justification. Yeah, Howman, we'll do that in a second. We gotta go through a lot of questions first. I want to build the foundation. Use it in your justification, but Neil, the more specific you can be, the better off you're going to be. All right? Keep that in mind. So this is going to take 28 days, 365 days. All right? Rotation is the same. You'll see the same point on the Moon all the way around. For the Earth to do 1 day will take 1 day, 24 hours. All right? So the Sun should be the largest. I don't know, make it a basketball. You could make the Earth a tennis ball. And you can make the Moon a marble. And that would kind of be like your real life size differential. All right. Number 4 now. Got to remember what it was. Why does day and night even exist? Day and night exists because half of the Earth can face the Sun at any time. Because the Earth can rotate, because the Earth rotates, day becomes night when the Earth is in its own shadow. So why do we have day and night? Because the Earth rotates. Only half the Earth can face the Sun at a time. The other half is caught in its own shadow. That we call night. The half facing the Sun's day. Day will turn to night, night will turn to day based on the rotation of the Earth. Okay? We rise over in the east, we set in the west because the Earth rotates counterclockwise. All right, every single day. So there we go. There's part 1. Part 2. What causes seasons on Earth? How does it cause them? 6. Draw a diagram of the Earth revolving around the sun. I have that diagram already made. We can just confirm and just talk about it quickly. All right. 7. Describe day, light, angle, and length during the summer solstice. And then during the winter solstice, how do they compare to the equinoxes? So then, let's jump over here. Here's number 6. We'll come back to that in a second. What causes seasons on Earth? How does it cause them? So clearly, the only variable that we're really plotting here on the Earth is the axis. We also have the equator, that's splitting northern and southern hemisphere, but it's this line right here, and whether it's towards the sun or away from the sun, that's going to determine what season it is. So keep in mind that it is due to the tilt and the spherical nature of the Earth that is going to result in more light or less light, more direct light or more indirect light to reach the Earth, different parts of the Earth. All right. So I'm going to actually write that out just to confirm it. The tilt and spherical shape of the Earth equals a difference in solar radiation towards the northern hemisphere and southern hemisphere. This difference is going to cause the seasons. All right. More light, more direct light, summer, less light, less direct light, winter. In between, equal mix of both, spring, fall. All right. 6, being able to draw this diagram. It doesn't matter which way you draw the axis. You can either draw it over like I did right here to the right, or you could draw the axis the other way and to the left. The thing is, there is no left or right in space. So I've been drawing the axis due to our warm-ups and notes and now the review, left and right, different directions, because I want you to realize I don't want you to memorize that summer is left, winter is right, spring is up, and autumn is down. I want you to use the axis. So I give the axis in different directions. That is intended to help you when you make the diagram to look at the axis. All right, you read the axis according to the sun. So in any diagram, find summer and winter first. You find summer and winter in the northern hemisphere by looking to see, is the upper part of the axis tilted into the sun or is it tilted away from the sun? In this case, it's tilted into the sun, so that hemisphere is in summer. It's the most extreme part of being tilted to the sun, so it's the start of summer, the summer solstice, June 21st. Okay? Winter, you look for that axis. Is it tilted in? Is it tilted away? It's tilted away, so there's winter. Find summer and winter first. Okay? If you can find summer and winter based on the tilt, you know the Earth moves in a counterclockwise revolution around the sun now, from part 1. You can then pick out what season goes in between. Summer to winter. What do you pass through? Well, you got to have your leaves fall off your trees, so you have autumn. Okay? Winter to summer. In order to actually get from snow, if we had snow, to the beaches, you need to have warmer weather. You need to have the trees gain their leaves again, so you need to have spring. So keep in mind where autumn and spring are between summer and winter. Okay? Then you can realize that it's just 3 months in between. All right? If we start June and December, then we're talking September and then March. All right? Usually, on average, they're around the 21st of those months. All right? Autumnal equinox and vernal equinox. Vernal meaning spring, Latin. Fresh, all right? refreshing of the planet or that area. Hopefully that's clear. All right. That was number 6. Number 7, describe daylight angle and length during the summer solstice and then winter, and how does that compare with the others? I'll go back to this one. Summer, winter. What are the ingredients? For summer, you need greater than 12 hours of daytime, and you need mostly direct light. Okay? Winter is less than 12 hours of daytime and is mostly indirect light. So these two situations result in more light and that light being direct, and that meaning warmer temperatures, more solar radiation, and that causes a shift of the climate from wherever it was to the warmest it's going to be. And in winter, less light, and of that less light, it's also mostly indirect, so it's also very weak. Therefore, there's not a lot of solar radiation being provided to the hemisphere at this point, and it's the lowest point. Therefore, we call this part in the shift in the climate to the coldest winter. All right, so it's doubly warm, it's doubly cold. Well, what happens in between? Autumn and spring are during equinoxes, which means daytime is equal. So it is exactly equal 12 hours of day versus night. And there is a mix of direct and indirect light. Most of the light is falling on the equator. Most of the direct light is falling directly on the equator. All right. So these two are called solstices. They're at their most unequal. These two are called equinoxes. Equal day and night. Equal direct and indirect light. Okay. Because if I go back to this picture again, you cannot tell where the direct and indirect light are falling on this planet because the axis is in parallel with the sun. It's not in line with the sun, it's parallel to it. Because it's parallel to it, the direct light falls somewhere along the equator and then the indirect light falls at the poles. Okay? So there's an even mix. Most of the direct light goes right at the equator, but there's an even 12 and 12 because the axis is not tilted in or away from the sun. So this diagram is incredibly important because it shows you number 5, and it helps explain number 7. All right. So if you have trouble with seasons, I'd make that diagram a couple times. Turn the axis one way, turn the axis the other way. Always going counterclockwise because that will tell you the correct answer. All right. So that was part 2. We've done part 1 and part 2. Part 3 and part 4 are quick. Part 3, draw a lunar phase diagram that shows the moon's position around the Earth according to the sun, and include length of time between the major phases like new moon and first quarter. It also includes full moon and third quarter, right? Draw the 8 phases as they appear from the Earth in chronological order. So from the Earth, how do they look? Being able to identify them. This is your lunar diagram just broken into 2 pieces. All right, so go back to March 11th, look for that diagram. It will help you answer the question. All right. I have, or I thought I had. There we are. I had the quick version of the diagram, number 8. In number 8, I put the sun on the right. I've been drawing it on the left a couple times. I've been drawing it on the right a couple times. Again, I don't want you to memorize new moon, full moon, first quarter, third quarter as up, down, left, or right. What I want you to memorize is how to make the diagram and to be able to identify new moon and full moon. All right. I want you to just remember, oh, new moon's to the right. Done. I want you to remember that new moon is the position of the moon closest to the sun because it's in between the sun and the earth. All right. Use a different color so it's easier to see. In between the sun and the earth, you will only see the half of the moon that is in its own shadow, darkness, its own night. You'll see the night side of the moon. All right. Well, what's opposite that? Opposite new moon, opposite the sun, is full moon, because that's the only way you'll ever see the entire day side of the moon, is if you have the moon reflecting its entire day side, reflecting all of it can see of the sun, back to you on the earth. Remember, the tilt of the moon's orbit is not perfectly at 0. There is a slight degree shift at about 5 degrees. So you don't have always, like later in the questions, we don't always have a lunar eclipse. We don't always have a solar eclipse. All right. So you find new moon, you find full moon. That is incredibly important because once you do that, remember the moon moves in a counterclockwise revolution around the earth, and then you can proceed to start filling in the phases. Just like in the previous diagram of seasons, you find summer, you find winter, you can move through the rest of the phases going counterclockwise. You find for the phases, new moon, full moon, you start moving counterclockwise, you can find the other phases. All right. So halfway, or really you go 1/4 in that orbit, like right here, and you'll get first quarter. You go 1/4, there's first quarter. Okay. Go 3/4 around the Earth, and there you go, there's third quarter. Sometimes third quarter is called last quarter because you are entering the last quarter of the revolution, but I prefer calling it third quarter because it matches well with trying to remember why first quarter is called first quarter. There is no half moon. First quarter and third quarter, yes, you do see half in day and half in night, but there is no such thing as called a half moon. It's first quarter and third quarter. All right. We had first quarter about a week ago. Now we're in wax and gibbous and we're getting real close to the full moon, which means we're getting real close to springtime, right? It's even later on in the study guide. So now I can pick out the phases. Crescents will always be between new moon and the quarters. Crescents will always be between the new moon and the quarters. A waning crescent is before the new moon. A waxing crescent is after the new moon, because now you're starting to gain view of the day side of the moon, right? And then gibbuses, or gibbi, I guess, will always be between full moon and the quarters. Okay? Waxing will be right before the full moon. Waning will be right after the full moon. It's flipped with the crescents. All right? Remember, gibbous means over halfway full, but not full. Crescent means under halfway full, but not completely empty. Quarter is half and half, but we name it based on where it is around the Earth. All right? What it looks like, I don't know if I drew it a couple days ago. Nope. What it looks like from the Earth, so number 9, one, 2, 4, 5, 6, 7, 8. Okay, we'll start with the new moon. We'll just kind of just go in order. We'll name them after we draw them in. So we start with a completely dark moon, new moon. We wax and wane from right to left. So if we just had the new moon, the next phase, therefore, between a quarter and a new moon, I just said was a crescent, but it's a waxing crescent. So we wax and wane from right to left. So the right side is going to be in daytime. Most of the moon will be in nighttime. All right. We've gone 1/4. Half is in day, half is in night. Again, we're going from right to left. Just like the Earth always is going to have the sun rise in the east and set in the west, we're always going to have waxing and waning. Our rising of the sun and setting of the sun on the moon from right to left, okay? After halfway full, we're mostly full. That's a gibbous, right? Most of it's in day side. The right side is in day side. Most of it's day, right side's in day, left side's at night. We're still waxing. Here, the entire moon, the day side's in full view. That's a full moon, full view, full moon. We're going to start losing the day side. The sun's going to start, quote unquote, setting with the moon. So now we start waning. And we always are waning or waxing from right to left. So then we keep going. The right half is now in night. And you just keep progressing all the way. Most of the moon now is in night. The left side, the sliver, is in day. What are each of these phases? Okay, well, I can pick out the quarters pretty easy because they're the ones that look like a half. All right, go from new moon to full moon. First quarter. Go from full moon back to new moon because we're moving this way and then going back again. Well, then this is going to be third quarter. All right. Between new moon and first quarter is a crescent. Am I gaining light from right to left here? Yes. So this is waxing. This right here is mostly full. That's a gibbous. We're still waxing. Then now the right side's in nighttime, so that's a waning gibbous. And then we're back to a sliver, so not waxing, a waning crescent. Okay, so this side is waxing, this side is waning. We're going from here and then back again to start. And that's the whole cycle. That's the point of view from the Earth. Okay? Part 4, an eclipse. Draw a diagram of a solar eclipse. Draw a diagram for a lunar eclipse. Include umbra and penumbra in your illustration. You can go back to the March 31st stream. Go to minute 8. That diagram right there will help you answer this question. All right. Believe I have the pictures left over. Search for that in a second. Yep. Draw a diagram for a solar eclipse. Draw a diagram for a lunar eclipse. This one's going to be quick. Always have the sun. Relative to the sun, the Earth is always kind of in a similar position. The moon is doing the most movement between these three objects in relationship to each other. And the only time we can ever have the shadow of each is when they're in alignment. So we can have the moon between the sun and the Earth. We can have the moon behind the Earth in relationship to the sun. Okay? They're moving in counterclockwise orbits, but we have to understand the nature of light, that we can have direct and indirect shadows. So the sun's light hits the moon at different points, and that establishes a direct and indirect shadow. Okay? Same thing for the Earth. Oops. This shadow keeps going, this light keeps going. So that's the max amount of light that can reach around the moon, reach around the Earth, and impact the Earth directly. All right? Hi, Kim. Keep in mind that this is not light, but a shadow. So this right here is the direct shadow of that object. And then some light is able to get from the south of the sun, or around from the north of the sun from the south. This right here is the penumbra, and then the darkest part of the shadow, the most direct part of the shadow, is called the umbra. So when the moon is in new moon, or when the moon is in full moon, is when you'll have these eclipses happen, because you have to have a straight alignment of the sun, earth, and moon. And the only way you do that is during new moon and full moon. The phase closest to the sun, new moon. Phase opposite the sun is full moon. Okay? The moon's umbra is casted onto the earth. The earth's umbra, the moon moves into the earth's umbra. Okay? That causes an eclipse. Again, an eclipse, blocking of the sun by one of these two objects from the other. The moon to the earth, or the earth to the moon. Okay? Why are lunar eclipses more common, and why do they last longer? Because the Earth's umbra is much larger. There's a greater chance that the moon, even with its off-tilt orbit, still ends up in the Earth's umbra. Why does it take so long for the lunar eclipse to complete? Because the umbra is so large, the moon is still moving into the Earth's umbra after a while. Solar eclipses are rarer because you need to be in a certain position at new moon during the day in order to have the moon's umbra land on you, and it's only a very, 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 very tiny area on the Earth. But it does trace like a line, all right? So you may be in the path of the umbra. That's the better way to actually see the eclipse, all right? So this is a solar eclipse, this is a lunar eclipse, and this was number 10. Okay? 11. Describe how to make a solar and lunar eclipse model using materials found in the classroom. Well, here's one example. I did this one a couple days ago. Modeling eclipses was not originally supposed to be just a simulator. It was supposed to be you guys in the classroom using a lamp, a tennis ball, and a marble to model eclipses. You were going to see the shadow of a marble on a tennis ball. That shadow would have been the umbra, and that would have been the location on the tennis ball where you would have seen a solar eclipse if you're like a tiny, tiny ant on top of the tennis ball. All right. So the lamp is the sun shining in all directions, radiating in all directions. You're not really going to see the penumbra, but you would easily see the umbra, the sharp, dark shadow. There may be some diffuse, fuzzy shadow. That would be the penumbra. All right, but you didn't see it, so you can't really make a connection to it. Just realize that this is more of like the last question, drawing a model, except now just realizing scale is involved. Tennis ball, marble, lamp being really far away. Okay, a lamp is much larger than a marble, but being several meters or several feet from the lamp, the marble will appear as the same size as the lamp. 1-to-1 aspect ratio, right? And that's what we have out in space. The moon, much smaller than the sun, but at its distance, it looks 1-to-1, same size. All right, so this is a solar eclipse because the moon's umbra is blocking the sun to the tennis ball. If I wanted to do a lunar eclipse, I would take my moon and my marble and I'd put it over there. Okay, now it's the Earth's umbra. Whoops, I erased my Earth. Now it is the Earth's umbra, and now that's a lunar eclipse because now the moon is moving into the umbra of the Earth. All right, that was number 11, and that finishes part 4. 3 questions left, and then we can get to our quizzes. All right. Again, I am going fast because a lot of this should have been done. If you've been watching, the goal is to pick out what you're not strong in, part 1 to 5, and double down and study that tonight, not studying the entire study guide again. All right? I think that's exhausting. It's a lot of information. So work smart. Pick out what you're weak in, work on your weakness. All right? Part 5 is talking about tides, daily tides, and then those special tides. spring tide and neap tide. All right. I did 12 a couple days ago. If you've been paying attention on stream, been checking the video. Draw a diagram of the high tides and low tides in the Earth according to different positions of the moon around the Earth. I don't want really focusing on the sun because that kind of implies later on spring versus neap. I want to save that for number 14. So this is the picture I used a couple days ago that I made up on the stream. Position A, position B, position C, position D in purple. All right. In position A, we have the moon in a new moon. We have the moon in a quarter, full moon, so on and so forth. But I want you just focusing on where the moon is. The moon will always have a high tide closest to it from the Earth. It's pulling water towards itself, right? Pulling water towards itself. However, the moon cannot reach all the way to the other side of the Earth, and so it leaves water on the other side, a little higher. Where we have the water getting pulled from, where the water level is low, see there's a lack of water, that is low tide. So low tide is the absence of water that's being pulled to a high tide. Just like how cold doesn't exist, all right, just a lack of thermal energy, low tides technically don't exist either. They're just the absence of the water getting pulled to a high tide. Okay? So closest to the moon and opposite the moon, high tide. Several people in the explain section of Roll Tide got this question wrong. If you are opposite the moon, if you're opposite on the other side of the planet, like right here, you are in a high tide. People assumed that because I said one answer was going to be obviously high tide, they thought the other answer was going to be low tide. No. You had to understand that the moon has an effect on the tides every 12 hours. So if you move from one side to the other of the planet every 12 hours, you're still going to end up with a high tide. All right. So you could be at this X the entire time, and that would be really one day for you. This is really one day. The Earth is rotating to different spots where the moon is. All right, over the course of time. I just didn't draw that. So that diagram is in Classroom that you can use. All right, that rotation every 6 hours. So what do I mean by that? Like I could have drawn this picture like this. So the moon could have stayed here, and the Earth would have stayed here. High tides here, high tides here, right? Say 6 hour rotation. I could have drawn that red X here. And so that's how you get the changing tides. The tides aren't actually shifting. It is actually you rotating on the Earth to a different spot or a different position away from the moon. Okay? So just understand the moon controls the tides here. Number 12. Moon controls the tides over the sun. The moon controls the tides. It determines high tide. It determines low tide. Even when we start talking spring and neap tide later on, the moon is the one that's setting high tide and low tide because the moon is closest. And gravity works by distance and then mass. Obviously, the sun is more massive, so it does have an effect, but the sun is so far away, the moon has the greater impact on the tides. Okay? Every 6 hours, you change tide from one to the other. Every 12 hours, you go back to the same tide. 13. Why did 2 high tides and 2 low tides occur on the planet simultaneously? Well, let's just go back to March 26th, if that's what we're going to use. I tell you to go to 27th, 26th. So this is the diagram I was talking about, diagram of the tides on Earth. Every 6 hours, you are rotating along with the Earth, away from the moon or opposite the moon, and that's going to determine high tide, low tide. The positions of high tide, low tide do not change according to the Earth, the moon, and the sun, except the Earth rotates faster than the moon revolves. You'll have different tides because you're moving along with the Earth. Okay? There are 4 tides a day because there's 4 positions. High tide, low tide, low tide. They alternate because the moon pulls water to itself and can't reach around to the other side. So every quarter turn, you have a different tide. Because there's 24 hours in a day, a quarter turn takes 6 hours. Because it takes 2 quarter turns to go back to the tide you were at, that takes 12 hours. So if we start at 12 p.m. noon, this is the new moon, we rotate to 6 p.m., quarter turn, another 6 hours, we go back opposite the moon, it's now 12 midnight. Okay, use this picture to help you diagram the tides on Earth. Every 6 hours a new tide, every 12 hours the same tide that you had previous. All right. They occur simultaneously because the moon is pulling water to high tide. That's why you have low tide to begin with. All right. 14. What is a spring tide and what is a neap tide? Last question. What phases are required for each? So our next picture, this is it. What is spring versus neap? All right. You need, for a spring tide, a perfect alignment of the sun, earth, and moon. All right. This alignment, like a solar or lunar eclipse. So yes, when you have an eclipse, you do have a spring tide, okay? In a straight line, the combined gravity of the sun and the moon has the greater gravity, the greater impact, but because the sun does have a small impact on the tides, okay? When the sun's high tide matches the moon's high tide, you're going to get a very high tide, okay? And then when the low tide of both match up, because they're in a straight line, then you're going to get a very low tide, a higher high tide, a lower low tide. This makes the tides more extreme. There's a greater difference between the two. When there's a greater difference between the two, we call these spring tides. So spring tides happen twice a month. They happen alternating weeks, new moon, full moon. All right. We left a quarter phase of the moon last week, and we're entering full moon. So we're transitioning from neap to a spring tide. The tides are getting less the same and getting more extreme. All right. Dotted line shows you the alignment. New moon versus full moon. Neap tides, you need a right angle, 90 degrees. Make an L, okay, of the sun, the earth, and the moon. If a right angle exists, you have a quarter phase automatically, first and third quarter. So we alternate, just like high tide, low tide, we alternate spring tide, neap tide throughout the entire month. This is over a month. This is over a day. Okay? This is over a day. This is over the course of a month because you're using lunar phases as positions. All right? Here, the primary reason for the tides is the Earth's rotation in relationship to the Earth. Here, again, it's the moon's positioning according to the sun. So daily tides are controlled by the moon and the Earth's rotation. These extreme special tides, extreme tide, minimal tide, spring tide, neap tide, they're controlled by the position of the sun and the moon. All right? So understand the difference there. Okay? When the high tide of the moon and the sun are against each other, then you're going to have a lower high tide because the sun's pulling some of that water to the low tides. And so you have a lower high tide than normal, and you have a higher low tide than normal. So the tides are more minimal. There's a smaller difference between the sea levels. Okay? If you guys have any questions, please ask through email or remind as you're studying rest of today, tonight. All right? The test itself will be several multiple choice questions, about 15 multiple choice questions. All right. Each question you will answer on a locked Google form, and then there's a follow-up question. The follow-up question is going to be an open answer. All right. You have to give me your justification. All right. How do you justify your multiple choice answer? You can either explain to me why the other answers that you didn't choose were wrong. That shows me that you understand process of elimination, that you also are able to know all the material that we've reviewed and be able to pick out things that we haven't talked about or why things are wrong answers. Or you can give me a real example, as best you can, of the answer that you chose. All right, that means things from class, that means things we've discussed. Normally, diagrams have been okay, except we're not doing this on paper and we're doing it through Google Form. So you can't really draw diagrams for every justification. So do the best you can in terms of description. Justifications are a way to show me that you know the information. So the more information you give, the better you'll do. All right. Doing the study guide helps you for the justification. This quizzes that we're going to do helps you with the quick recall, being able to pick out right answers. All right. So you got to be able to justify your answer, cuts down lucky guessing, and shows me that you know the information. All right. More detail, the better, as much as you can provide to me. When you're done, you submit the form and it's all taken care of. I'll grade it as people finish. So technically, it's got to be done before midnight tomorrow. I'll be posting it at 10 a.m. There is no stream tomorrow. You'll be taking that form at 10 o'clock. Hopefully, get it done with. Take about an hour, maybe a little more. Submit it. We're done. All right. You do have the whole day, but I suggest you get done around that 10 a.m. time frame so I can answer quickly any questions that you have through email or remind. All right. Why not no stream? Because you guys are taking the test. What do you want me to do? Just sit here and look at you? And also, it's in a locked form, so I don't know how you're going to be able to watch it. You lose all your tabs. All right, so there is no stream tomorrow because you're taking the test. But if you have questions, use email or remind. I'm going to quickly get back to you as long as it's in the usual time frame. All right? So I suggest you take it around 10. I'm going to post it around 10. Take it then, submit it. All right? Questions on that? All right. So quizzes. You can use anything, a phone, your Chromebook, another computer. Go to joinmyquiz.com and enter the code. Use your actual name. I'm going to kick you if it's somebody else. Thank you, Downey. Frost you a pair? What is that? Jake Rainey was talking a big game earlier. See if you guys can take him down. Azra and John are sloths. That's cute. Hey, Troy. The Maddies. Give you a little more time. Rainey's going to be light work to take down Rainey. Downey's going to have light work. Okay. Good. Haven't had any other people join. You know, I don't know if finishing early is the way to win. I think if you go slow, take your time, get as many points as you can without losing anything, it's not like a Kahoot, you know? It's about accuracy, I think. Sorry, Art. They are mainly based on time, John? I don't know. Maybe I'm used to seeing certain people trying to answer as many questions as possible, but they get a bunch wrong, so they don't do as well. Alright, we good? We got 20 some of you watching, 18 you joined, Cody just joined. I'm gonna start. All right. 3, 2, 1. Wait for the stream to catch up. Go. I also want to see a nice high group accuracy. So loud. Oh boy. It's tough because my desktop audio isn't the same as what I'm actually hearing. Downey and Hike on a perfect streak right now. So Hike had an extra 60 points because of better timing. Hike is still on that nice perfect streak. I guess Downey is answering faster. Take a look at some of the questions, how we're doing on some of them. Come back to the leaderboard in a little bit. Hey, we just gotta study. What moon phase will occur 2 weeks after a waning gibbous? So remember, you gotta go opposite in the phase diagram. What's opposite of waning gibbous? What moon phase takes 1 week after a full moon? Come on, 1/4 turn after a full moon? During a total lunar eclipse, does the moon always turn red? Always? Or can it be partial? So the phases are hurting right now. Hike's still in the lead. Hasn't missed one. Hasn't missed one. You make Newton proud. Oh, Hike. Rainey's in second, now he's in third, now he's in the second again. Come on, someone's got to knock him down. No, he's smart. How are we doing on questions? We've done better since before. Only 3 are really hurting people. Which position is the Northern Hemisphere experiencing winter? So again, in that diagram, look for the axis. Look for the axis. You're the northern hemisphere. Which way are you tilted away from the sun? Which way are you tilted away from the sun? Either going to be A or C, right? Which phase is this? Oh, come on, we don't have half moons. It's a quarter. Which quarter is it? Which one has the waning side associated with it? Right side is in nighttime. June 4th has a waxing gibbous moon. What moon phase will occur on June 10th? So about a week, about 6 days, 7 days away from the waxing gibbous. What's opposite waxing gibbous in the phases? Go across the diagram. The reason why the sun appears to rise in the east and set in the west. Oh, come on. We talked about that. I talked about literally rising in the east, setting in the west. Just so aware too, on the line, 5 G-Bucks for first place, 2 G-Bucks for second place, and then 1 single G-Buck extra for third place. Yes, I'm still tracking them. What are we going to use them for? Don't know yet. You can practice after, Charlie. Post the link in Classroom. You guys can use whenever. Downey's building a streak. Kim's got a small flame going. Hayden, I thought you said you were doing bad. Just jumped into second. Oh, never mind. Well, then we have, a little more studying to do, Eric. Maybe a little practicing on the quizzes, too, can help later on after we take it. This is an okay accuracy, team-wide. Yeah, we think he sees the mailman. Carl Sagan appreciates Hike's mastery of astronomy. Good. Be haunted by a genius. Maybe it'll help you on the test, John, because where are you right now? Oh, 9th. Hayden's on a massive streak. What question is still haunting you guys? June 4th. It's all the phase placements. Exactly. Know the placements. June 4th has a waxing gibbous moon. What moon phase will occur on June 10th? June 4th has a waxing gibbous moon. What moon phase occurs 6 or 7 days from then? Gotta remember the picture. You done, Rainey? We'll check the leaderboard in just a second. What phase is opposite the waxing gibbous moon? Here's waxing. Number 4. What's opposite the diagram? What is opposite the diagram? 8? Oh, what's 8? Oh, okay. Hayden, 26 in a row? You're done. Hike is done. See if anybody else can actually catch. Jack's on a big streak. If he answers them quickly and keeps that streak going, he's going to jump. See, Jack's moving up. Slow and steady. See how he goes. Anybody else got a shot? Maddie, nice streak. .8 seconds. Wish you could click on that and see some stats. As you guys finishing up, number 24 still tripping people up. Still! Even I showed you the picture. Guys are too focused on the questions though. So lunar phases, being able to pick them out visually, being able to know their timing, that seems to be the biggest thing. Timing isn't going to play a big role in the test. Obviously, it's going to be pretty balanced. Know the lunar phases because, I emphasize that on this Quizizz, because they relate to the eclipses, they relate to the tides, they help you in understanding why the seasons, the extreme seasons, where they are in terms of close to the sun, away from the sun, the tilt, all right? Jack lost his streak. Oh, no. Kim might knock you out of the top 3, Rainey. Once Jack and Kim are done, I'll kind of end it. Hayden and Hike are pretty much set into 1 and 2. I'm stressing, okay? Down here, everybody gets the same questions, just out of order. You weren't getting picked on by the phases. I emphasize the phases. Kim finishes in 4th. See where Jack goes. Everybody's watching Jack. You gotta jump 3 spots, Jack. Keep your streak up and answer fast. Make Newton and Sagan proud. Or even make Einstein proud. Oh, he's off my screen. It's a good name for a cat. Always land on their feet, right? They subvert gravity. Ah, Fig Newtons. Oh, Jack passed Downey and Kim. He's gonna knock Rainey out. He just needs 1,000 more points. Less than that. 700. And Jack knocks out Rainey. Oh, man. You lost a G-Buck, Rainey. You had it in your hands. Can he beat out Hike? I think he's got too many wrong. How about 50 cents? How about no, Rainey? How about you get nothing? Can he get an extra 400 points? No, he needs 4,000. Never mind, he's not getting it. Good job, Jack. So, our top groups. We had a 78% accuracy. That's okay. It's not great. Some of the questions we really got to focus on, some of the RNG questions. If you were towards the bottom and you're still going, that's fine. But we really got to work on, what does the word solar refer to? Solar is the sun. When the moon is at a full moon or new moon, what type of tide will you experience? When it's in a straight line, you need to have a perfect alignment. It's going to be spring tide, right? When sunlight's filtered and bent in the atmosphere, this causes the red appearance, right, in a total lunar eclipse. Lighter part of the shadow, penumbra, all right? So there's a bunch of eclipse questions in here. When you're looking at the seasons diagram, remember the axis can be pointed to the sun, away from the sun. It can be left or it can be right. Always going counterclockwise. In the northern hemisphere, look to see the top of the axis. Is it aimed at the sun or is it away from the sun? Find summer, find winter. Then you can find the other seasons. Okay? Bulges of water, tides. All right. Why do we have a change in day and night? These phases are tripping you up. These are quarters. They're not half moons. They don't exist. Okay, which moon is which? First quarter is in the waxing side. Third quarter is in the waning side. All right. So keep that in mind as you're going through some of these, picking out the phases. Knowing the timing of the phases seems to be the biggest issue. The eclipses and the phases. You seem to be okay with seasons, the reason for the seasons. You'll identify the seasons, you still got to be able to do. I am warning you, there will be a bunch of diagrams. You will need to be able to pick out certain locations of the moon to help you figure out tides, phases, all right? Not so much the eclipses, all right? But really focusing on tides and phases, all right? There is going to be no rematch. But I will be posting this link to take this as a practice. Oh, we're going up in accuracy. Our slow and steady guys and girls at the end. All right. I will be posting this as a practice in Classroom. You can retake it, and then you can restudy the study guide. This will help you in terms of finding the right answer during the multiple choice portion of the test, and then this study guide is going to help you do the justification. All right. Tomorrow at 10 o'clock, I'll be posting the test. Take it. Around then, I can help you if you have any questions. There is no stream because you can't watch it at the same time that you are taking the test. Just on your Chromebook, you'll be locked into a Google Form. Also, it's got to be on your Chromebook. All right? Be on your Chromebook. Okay? Any questions? Other than rematches? No? All right, guys. Good luck tomorrow. Ask me questions if you have them. Oh yeah, I forgot. There's also me. It's pretty good. Thanks to my wife. Bye Kim, bye Ryan, bye Hayden, bye Downey, bye Charlie, bye Kaylee. Bye Rainey. I'm gonna take away 25 cents from your budget. See you, Jack. Bye, John. If you're cringing, I did the right thing.